Okay, we're gonna go over some examples of all the different 4 types of naming. First thing we're gonna do is our ionic compounds. So here we have K3P. And the reason this is an ionic compound is because we have K, potassium, which is a metal, and we have P for phosphor, which is a nonmetal. So we have K, a nonmetal, and a metal mixed together. That makes it an ionic compound. So how do we name this ionic compound? We call this just potassium phosphide. If I give you calcium nitride and asked you to come up with a formula for that, we would need to know what symbols are for calcium, and which symbols are for nitride, and what the charges are for both of those elements. This again is an ionic compound because we have calcium, a metal, and nitride, a non-metal. So again, calcium is over here is Ca, it's a metal. Nitrogen is over here, which is nitride, which is a non-metal. So we have Ca and N. The charge on calcium is 2 because it's in column 2. The charge on nitrogen is 3 because it's in column 15, and that is a 3. So calcium is a 2 plus and nitrogen is a 3 minus. And we get Ca3N2. And how I got that is that I dropped the signs. So 2 plus and the 3 minus, those signs drop. Then we cross the charges and we put them down below. So the 3 from the nitrogen goes on the Ca. The 2 from the Ca goes on the N for nitrogen to get Ca3N2. Next one we have is CO2O3. So CO2O3, CO is cobalt, somewhere on this periodic table, right there. And cobalt is a transition metal. O is oxygen, which is a nonmetal. We mix a transition metal and a nonmetal, that is a multivalent compound. So we need to use Roman numerals. What we have to do with this is name it, but we also need to figure out what charge is on cobalt. So I'm going to cross back the charges. So cobalt would have a charge of 3, and oxygen would have a charge of 2. Oxygen charge is supposed to be 2 because it's in column 16, it has a 2 minus charge. Therefore, cobalt is a charge of 3. So we name that cobalt, C-O-B-A-L-T, cobalt 3, Roman numeral, and then oxide. So again, always changing the ending to IDE for these compounds. Another example would be gold 2 fluoride. So here we'd have to come up with the formula. This name is telling us that the charge on gold is 2. So gold is Au from the periodic table. We find it in here as gold. Gold is a transition metal. That's why that 2 is there. It's Roman numerals. Fluoride is fluorine. That has a charge of 1. We then cross the charges and drop them, and that compound becomes AuF1. F2, sorry. AuF2, just like that. Another example might be FeS. So if I have FeS, Fe is iron from the periodic table, and that is found here. And it's a transition metal. And then S is found over here, which is a nonmetal, so that makes it a multivalent compound. So we want to cross back the charges. That makes it Fe1 plus S1 minus. And then we want to figure out what the Roman numeral for 1 is, which is just an I. So we have iron 1 and then sulfide. Always changing the ending to IDE. Another example might be MnCl. O2. So Mn is manganese, and we find that in the periodic table in the transition metals. So again, it's a multivalent compound, and O is over here for oxygen. So crossing them back, we get Mn2 plus O1 minus. However, O is not supposed to be a 1 minus. O is supposed to be a 2 from the periodic table. We can see that there in our charges. So we have to multiply these compounds by 2. So multiply both parts by 2. That would then give us Mn4 O2, the way that oxygen should be. So when we're naming this, it then becomes manganese, G-N-E-S-E 4, and then oxide. So O is oxygen, and we change the ending to oxide. So the next one, if I give you, is barium phosphite. So barium is on a periodic table. That is a metal over here called Ba. However, phosphite does not have an IDE on the end of it. Therefore, it's going to be one of our polyatomic ions. So we check our polyatomic ion sheet for phosphite, and that is going to be PO3 with a charge of 3 minus. PO3, charge of 3 minus. And barium had a charge of 2. All we do here is just cross the charges. So it becomes Ba with a 3 on it. And then we have PO3, and that whole PO3 with brackets has a charge, or has a number of 2 on it. So Ba3, the 3 came from the phosphite. PO3, the whole thing with brackets, has a 2 on it from the barium of 2. Another example of this would be if I gave you copper, 2 silicate. So copper is Cu. It is a transition metal from the periodic table here. And it has a charge of 2 because that's what that Roman numeral is for. Silicate, again, that doesn't have an ending in IDE, so it makes it a transition metal on our, makes it a polyatomic ion from our polyatomic ion sheet, which is right here, it looks like SiO3 with a charge of 2 minus. SiO3, 2 minus. Again, we just cross the charges. So we have Cu with a 2 from silicate. Then we have SiO3 with a 2 from the copper, just like that. However, when they're both 2, we can reduce these. We can reduce it to just Cu, SiO3, just like that. This time instead, if I give you the compound, so FePO4, 2. Fe we know is iron, it's a transition metal. PO4 is a whole other compound together. Since it has 2 capitals, it's going to be one of our polyatomic ions. So we need to find PO4 on here. PO4 is phosphate, and it's supposed to have a charge of 3. So when I take these and I cross back the charges, it should be Fe2 plus PO4 1 minus. We just said that PO4 for phosphate needed to have a charge of 3. It does not have a charge of 3, so we need to make it have a charge of 3 by multiplying by 3. That gives us Fe6 and PO4 with that normal 3 it should have. Fe is iron, so it's going to be iron with the 6. And then PO4 we said was phosphate. PHOS, phosphate. Just like that. Two more examples here. So if I give us something that looks like P5S2. So P5S2, what is P? P is phosphorus. And what is S? S is sulfur. Those are both found on the periodic table underneath the nonmetals. Since they're both nonmetals, this compound is a molecular compound. So we use the prefixes. 5 is going to be penta, 2 is going to be di. So it's going to be pentaphosphorus, and then disulfide, again changing the ending to IDE. And then vice versa, if I gave you the compound trichloride monobromide, trichlorine, sorry, CLORINE, chlorine monobromide. We know that tri is 3, chlorine is Cl, mono is 1, and bromide is the compound bromine, which is Br. So Cl3 and then Br with a 1 on it, just like that.